Alright, I'd like to go over two of the homework problems. We'll start with number 2. So homework problem number 2 states we have a simple pendulum which consists of a 3.0 kilogram mass hanging at the end of a 2.0 meter long string that is connected to a pivot point. Alright, so I have my pivot point here. I have my 2 meter long string connected to some mass. So this distance is 2.0 meters, and our mass equals 3.0 kilograms. So for part A, do part A in blue, it says when it is hanging straight down. So if we're trying to find torque, should probably draw it a little better. It's not T. It is a pow. Torque equals force times distance times the sine of the angle. So in example A, our force is straight down. Our distance is straight down. We're in the same direction. So remember, force is mass times acceleration, so our force is 3.0 times 9.81 times our distance, which is 2.0 meters, times the sine of, well, what is our angle here if everything is in the same direction? It's going to be 0. Okay, so sine of 0 is 0, so if I plug all that in, I get 0 Newton meters for the force on part A. Now for B, it says for an angle of 15 degrees. So what we're going to change is our angle will now be at 15 degrees. And we're still going to have our force, and we're going to have our distance, but they're not in line any longer. So here torque is going to equal this same mass times the same acceleration times the same distance, but we're changing our angle to the sine of 15. And if we throw that in our calculator, we should end up with 15.2 Newton meters. And then for part C, it says when it is swinging with a velocity of 15 meters per second at the bottom. So for part C, we have our pendulum. It is moving in this direction with a velocity of 15 meters per second. We have the same mass. We have the same distance. Now, basically, this is just extra information. Okay? We're still trying to solve for torque. Torque doesn't ask you anything about the velocity of the object. It is still 3 kilograms. Gravity is still 9.81. The distance is still 2.0. And what is our angle here? Well, it's at the bottom. It's still straight up and down. So our angle is going to be 0. Sine of 0 is 0. So 0 times anything, we end up with 0 Newton meters. So that's question number 2. The other one I want to go over is question number 3. Okay, so number 3. I also went over this one in the levers video that I just posted today. So number 3, we have a screwdriver trying to pry open a can of paint. So we have our can of paint. We have a screwdriver. All right, so we're pushing down our input force is at this point on the screwdriver. Our output force is over on this end trying to pry the lid up. Now what we need to figure out are our distances. Alright, so what we're trying to do here is F in times the distance in should equal F out times the distance out. Okay, and this comes from our mechanical advantage. F out over F in equals D in over D out. So if I just do some cross multiplication, I end up with this setup down here. Okay, so my force in, my force out, I know those. I know where they are. The other part I need to figure out are my distance in and my distance out. Well, one thing they give us is the length of the entire screwdriver. The entire screwdriver is 23 centimeters. And they tell us that a 84.3 Newton force is applied at the end. What is the force on the lid, which is 2.00 centimeters from the other end. So this distance here, our distance out, equals 2.00 centimeters. So if my distance out is 2.00 centimeters and my entire screwdriver is 23 centimeters and my fulcrum, should draw that in there as well, my fulcrum is located right here on the edge of the can, that's going to mean that my input distance is 21.0 centimeters. Now, just as a side note, if I redraw it, I have my fulcrum here, I have my output force, or my load on this end, and my input force on this end. What type of lever would this be? This is a first class lever with the fulcrum in the middle. Alright, so now I plug my numbers in. My force in is given to me in the problem at 84.3 newtons. My distance in, we just solved for that. We're given 21.0 centimeters. I want to use meters, so it's going to be 0.21 meters. And that's going to equal my force out, which I'm trying to solve for, times my distance out, which was given at 2.00 centimeters, which would be 0.02 meters. So I'm going to divide both sides by 0.02. And I'm going to end up with a force out equal to 885.15 is what I get out of the calculator. It's a force, that'll be in newtons. If we do our 3 sig figs, it would just be 885 newtons. The answer key in the packet gives you 885.2 newtons. As you can see, any of those answers are approximately the same. Just all about rounding and significant figures. So hopefully that helps get you started on the homework problems. If you have any other questions, please reach out and let me know. Have a great night.